Okay, this video is going to be about how to determine the rate of a chemical reaction from experimental data. The experimental data which you can use can be almost any change which can be measured. Ordinarily, it should be the change in concentration of product over time, but it could equally well be the change in concentration of reagent as well. The only thing to remember is if you're measuring the change in concentration of reagent, the rate is going to be the inverse of the change in concentration of reagent over time, since rate must be a positive value. Instead of concentration, because often concentration is not easy to measure, we can also measure the change in mass. If there's a change in mass, for example, if gas is being lost, we could also measure the change in volume of gas being produced over time. We could look at the change in pH. pH is obviously a measure of the concentration of hydrogen ions in a solution. We could measure the change in conductivity, electrical conductivity, which will change if there is a change in concentration of ions dissolved in a solution. And we can even measure changes in values which are not necessarily easy to assign a number to. For example, changes in colour or changes in opacity of a solution, so whether or not light will shine through it, whether you can see through the solution. If you're doing one of the latter things where you're measuring a change in appearance, normally what you do is you decide on a specific appearance, and when that appearance is reached, you determine the reaction to be complete. And what you can do is you can assume that the concentration at that moment has a value of 1, and so once you've reached that concentration of 1, the rate is simply going to be 1 over the time. Anyway, so if we're measuring the change in a measurable value, for example, concentration or mass or volume or pH or conductivity, the graph will always look quite similar. So what you will have on your axes, on your x-axis you're going to have the time. So you always have to be measuring something over time when you're measuring the rate of a reaction. And on your y-axis you're going to have your measured value. Which I'm going to go with concentration of product. That is the official definition of rate of reaction. Now, no matter what value you're looking at, assuming you are looking at the change in quantity of product, be it concentration or mass or volume, you will always see the same shape graph, and it will always look something like this. So it will start off steep and gradually flatten off. Obviously, if you're measuring the change in concentration of reagents, your graph will be the inverse, so it will start off steep going downwards and gradually flatten off because the concentration of reagent decreases as the reaction progresses. The reason why the graph looks like this we'll go into in a next lesson. However, the initial rate is going to be the steepest. The initial line is going to be the steepest right at the beginning, and it gradually flattens off, essentially because we're consuming the molecules of reagent, and therefore it's more difficult for them to react with each other, and so the reaction slows down. So to find the rate in a reaction, you need to find the gradient of this line. Now, since it's a curve, we can't just simply take 2 points on the line and measure the rate between them, because if we were to do that, what we would do is we'd find the average rate between wherever those 2 points were, and wherever you decide to put your second point is going to change the overall rate of the reaction. If you go later, the line is going to be flatter, and therefore the rate is going to be slower. So we try to avoid finding an average rate, because that doesn't really tell us very much, because if you wait long enough, the rate is going to tend towards 0 anyway, because the line is just basically going to be flat. So what we need to do is we need to determine the rate at a specific time point, and we can do that by taking a tangent to the curve at the time which we're interested in. To take a tangent to the curve, we just draw a straight line which is touching the curve at a single point. Now, you could do that for any time, but the time that we're most interested in is the time right at the start of the reaction. So right at the start of the reaction, where the line is steepest, that's where we want to take our tangent, and our tangent will only touch the line at this time 0, and that line should be the steepest point on that curve, because that's when the reaction is going fastest. So we can take a tangent to the curve, and then we can find the gradient to this tangent by looking at the rise over the run. So picking any 2 points on this straight line and finding the gradient of that. And that gradient is then going to be able to enable us to calculate the rate of the reaction at time 0, where we can have our change in concentration of product in this case over the time it took for that to happen. So this is how we can calculate the rate from experimental data.